So I am E Krishna Rao Patro. Today we will discuss about one more important topic, that is merge sort. Merge sort is one of the important sorting technique where which applies the divide and conquer algorithm. It will divide the input array into two halves and calls itself for the two halves and finally merge the two sorted halves. This is one of the very important and easy sorting technique. The merge function is used for merging two halves. The merge function, which is a key process that assumes array of from starting to middle and middle plus 1 to last. So it will be keep on merging the two halves. The merge sort algorithm takes the three parameters merge array and left index and right index. The left index is the lowest index, the right index is the rightmost index. If R is greater than L, then it will find the middle point first, middle point of the array. How it will find middle point? By dividing the low index plus right index by 2. The low will be always starting position, R will be always ending position. And then it will call the method for the two halves. For the first half, L to M, because M is my middle. Then second half, M plus 1 to R. And after that, then it will do merging. Merge the complete array L, M, R. So this is a small algorithm and the time complexity will be order of n log n, because n time it will divide and for every division it takes log n time. So totally n log n time. For example, there are set of data lengths 38, 27, 43, 3, 9, 82 and 90. These are the given data. So what it will do? It will divide the whole data into two parts. 38, 27, 43 the first half, and then next half will be 9, 82 and 10. After dividing into two parts, again this division will be again divided into two parts. 38, 27 will be first half, then 43 and 3 will be second half. Next, this right side. Again 9, 82 will be this half and 10 will be this half. So it is keep on dividing. How long it will divide? Until the element become single one. So now 38 and 27 having two elements. So it will divide into again 38 and 27 is, and this will be divided into two. It is keep on dividing until it reaches the single value. Now this 9 and 82, it will divide again two parts. 9 and 82. And the 10 is single one, so as it is. So now when you reach here at this level, all elements are now single. Whenever the single level stages reaches, that time it will do merging. While merging, it will merge in a order. But now observe here, 38 and 27 both belongs to same parent, because 38 and 27 belongs to same parent. Now that will be merged. While merging, first 27 comes, then 38 comes. Not 28, because if at all you need ascending order, then 27 first, 38 next. Similarly, observe here 43 and 3. So 3 comes first, then 43 comes next. Okay, that means here the merging process starts. Now it will merge 9 and 82. So 9 is already smaller, no need. So as it is. 10 is single, keep as it is, because you have to check whether both belong to same parent or not. Now observe here 27 and 27 and 38, and here 3 and 43. These two will merge. While merging, it will merge in a order. Now first it will take the first element of this first half and first element of second half. Among these two, which is smaller, that will come first. So 3 comes first. Then the control comes here. Checks 27 with 43. Whichever is small, that will take first. So 27 is small. So that means 38 means the pointer has come here. Next, check 38 and 43. 38 is small, so 38 comes next. And then it has come out of the boundary, that means this part is over. Then 38 is over, then 43 is remaining. So 43 is copied. Similarly, here in this half, 9 and 82. So merge. And here 10. Now these two will be merging. It will compare 9 with 10. Now 9 is smaller, so 9 is copied. Then the control has come to here. And 82 and 10. 10 is smaller, so 10 has come here. Then remaining 82, it will copy here. Now these two will be merging. While merging, it will sort it. So 3 come first, and then 9, and then 10, and 27, 38, 43. So this is the process of merge sort. So you can observe here. Initially divide it into part, again divide into part, again individual. After that, it will try to merge. Whichever is small comes first. Then these two will be merged. Whichever comes, because it will check whether both belong to same parent or not. Now 7 and 8 belong to same parent. So 7 came first. 2 and 4 already in the order. So no need to do any change. So merging. Now again, because these two belongs to this same parent. So 1, 3, 5 and 6 comes to 1 half. Again this part now it will merge. Now 7, 8, 2, 4. So 2 comes first, then 4, then 7, and then 8. Then it will merge these two. So 1 comes first, and then 2 come from this part, and then 3 come from this part. Because here every time it will compare with both the values from both half. Whichever is small, that comes first. So 1, 2, 3, 4, 5. Then 6 has come. Then 7, and then 8. Finally, this way, this algorithm works. Fine. So you can see, observe here. This is the simple diagrammatic representation of this method. A small video representation. Okay. You can see how this works also with another example. First, the 100, 20, 15, 30 and 5, 75, 40. It will divide in two parts. Again, this first half, again divide in two half. Second half, again divide in two half. So, it will try to divide into exact half. If there is a odd number, then one side 2, other side 1. So, one side will be more. It is keep on dividing. How long it will divide? Until you reach the single value. Once you reach the single value, then it will stop the process. After stopping this division process, then it will try to merge. Now this is merge, this is merge, this is merge, and this is merge. Now these two are merged because both belong to same parent. These two are merged because both belong to same parent. After this, now this is one half, this is another half. Please observe here. And then merging into two parts. So while merging, the data will be coming in an order. Okay. So you can see here. The original value of this divided in two parts, 99, 6 and 86, 15. And here 58 and 35 divided into part. Again right side will be 864. Then keep on dividing 99 and 6, 86, 15. Because until you reach single value, it will divide. After reaching into, now here 4 and 0 still divided. Here 4 will come per, 0 will come. Now trying to do merging. While merging, both must belong to same parent. You can observe here 699 because it comes into order. 86 and 15 means 15 come first and then 86. 58 and 35. So 35 come first and then 35. 58. So this is the way the merging occurs. So finally it will merge into a single array. So once merge, then you will get the sorted array. This is the way the method works. The algorithm, you can see, you can pass the array. Then you can find the middle value. How to find the middle value? Whatever the parameter you pass, the lower index and high index. So low plus high by 2, you'll get the middle. After finding the middle position, then you call the method again 2 times. Because for the first half as well as second half. The first half will go from low to middle and second half goes from middle plus 1 to high. So this is keep on dividing. And then once the 2 halves created, until this will be keep on dividing until you get a single valued list. Then later on the merge function will be called. It will be merging the 2 halves. So this process will be keep on continuing until the low is less than high. And while merging, you can see this algorithm. First, you can take the starting position. P will be starting and Q will be middle plus 1. And here it will take one temporary array. It will take a temporary array because while merging, it will store in a temporary array. From the temporary array, it will go to the original array. So my temporary array is B. The B's length will be ending minus start plus 1 because that will be depending upon the size of the 2 halves because the 2 data will be stored in the B. Now here, how long it will do? There is a small process. Initially, where I have to start? I have to start from beginning, I equal start, and until I less than n, it is keep on going. It will check. In the loop, it is checking whether P has crossed the n. If P is greater than mid, then the remaining part of the A will be stored in the B. Similarly, if Q is greater than n, then the remaining part of that half will be stored in K. So, these two will be done after the entire thing is, that means the left part means leftover amount or the elements will be copied into B directly without comparing. Otherwise, if A of P is less than A of Q, because P points to left to first half, Q points to second half. If the A of P is less than A of Q, then A of P data will be copied in B of K. K starts from 0th position. So, this process is checking whether data is less or not. Whichever data is less, that data will be copied. If A of Q is less, then A of Q is copied. So, this process is going on how long? Until I is less than n. Until I is less than n. So, repeat this process. And finally, when entire thing is copied, then here it will do what? From B, because B is my temporary, I told B is the temporary. From B, it is copied to again A. Because wherever starting is there, from the starting position, the P will be, because now my P equal to initially start from 0, from 0th position of the temporary B will be copied to A until K elements, because K number of elements are there in the B. So, once this is copied, the original array is now in the order. Now, the time complexity in the best case for the method is order of n log n, and the worst case also order of n log n, and the average case also order of n log n. That means in every case, whether you give the data in sorted order or unsorted or in random order, in any case, the time complexity will be same. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.